In this section, I'll be talking about projecting this part into two views, one front section view and one side projection view. And I will also demonstrate the parametric capabilities of the software. I started by creating my layers list here and giving them the proper attributes here. And now I'll change to my rectangles layer and I'll create the rectangles in which I will draw the projections. As we can observe, the largest diameter here is 60 and the height here is 50. And these dimensions give us the overall dimensions of the part. I will consider a layout similar to this, where I have an A4 format as well as a title block with a height of 40 millimeters and a length of 185. In this scenario, the two rectangles fit perfectly inside with a calculated A and B for the empty space of around 462 for A and 45 for B. And here is where I will place my front view, and this will be my top view. So I'll have to create my axis lines. I'll have to switch to the axis layer. And since this is a cylindrical part, I need only one vertical axis here in the front. So line enter, MID enter, click, MID enter, click here, and I'll extend that, extend, double tap enter, because I need it in the other rectangle as well. Okay, and then I'll trim and double tap to trim that part out. Select this one, activate ortho command, go like that for 3 millimeters and 3 downward. Also, I can use the scale command. This is more precise. 3 and 3. All right. And I can't see the scale, so I'll have to give the LT scale command, enter, and give it a value of 7, for example. And the top view, I need another axis line like that. So line, MID, click here, MID again, here, and extend these out by 3 and 3. Okay, and I finished drawing my axis lines. Now I'll switch to my thick lines layer, LA enter, double click thick lines, and let me create my top view first. So it's a series of circles, 20 millimeter circle, 40 millimeter circle, and 60 millimeter circle. So C enter, D enter for diameter 20, enter to repeat the command, the add symbol to start from the same origin point, D enter 40 to give the other diameter, and once again tap enter to repeat the command, give the add symbol and enter to start from the origin point, D enter for diameter and 60, and this is my top view projection. For my top projection view I finished, but for my front projection view I'll be using a command called XLINE, and this command will help me with my corresponding edges. I just give the command, click on an edge, and I have an infinite line that can help me with my corresponding edges. Since I have my ortho turned on, this can only go vertical or horizontal. And all I have to do is click and tap enter to finish the command, and I'll do this for all of my 3 diameter circles here. Like that, and on the other side. Oops. So XLINE. And now I'll be using the line command, and this will be a section view. So this is a through hole. So all I have to do is draw a line to overlap this, like that, and this one. And I can also, to help myself, I can use the explode command to explode this rectangle, and offset with the offset command by 15 this edge, like that, and let me place it on my thick lines layer because it's on the rectangles layer. Okay, I'll have to also trim it here. TR, enter, enter, and then click on what you want to erase. Okay. Now I will delete my corresponding edges here with the delete key. Also have to trim this, and I will offset this edge here by 10, like that. Then extend, double tap to extend this and that, and enter, and trim and double tap to trim this edge and this edge. And now all I have to do is draw the missing lines here, the missing edges. Okay, and I'll have to switch to my hatch layer to draw the hatch pattern. So hatch, enter, click here and click here and enter, hatch edit, click, and from this menu we'll change the scale to 15. Okay, and now we can go to the layers list, to our rectangles layer, and turn off the rectangles visibility so we can see the finished projection of the section and the projection view. Now we can move on to drawing the trace section label here, so extend that by 10, and here. Now create the arrow with the polyline command and click somewhere, add symbol, actually W, enter, 0.5, enter, 0.5, enter, add 10, 0, enter, then W, enter, 1, enter, 0, enter, add 4, 0, enter, W, enter, 10, enter, 10, enter, add 0, 0.5, 0, enter, and enter. And then we'll rotate this, so rotate. Okay, and we want to get the middle here. That's it. And since I have my ortho on, I can rotate it 90 degrees. Now I'll place my M text here. It's the H, enter to put the height to 7, and click here. Is the A. Move the A next to the arrow, like that. And now mirror it, like this, against an imaginary axis. Click somewhere, hold shift, or rather don't hold it because the ortho is already helping us to draw a straight line, straight axis, and click. And then tap enter to create the other one. Now all we have to do is move them in the proper position. So move, select, grab it by the middle of this line here, and place it here at the end of the line. Similarly, move, enter, select it, MID, enter, go in the middle, and place it here. And now place the title of the section, or actually the section label. So M text, enter, click, H, enter to be sure it's 7, click, and then A minus A to have the symbol, and it's placed near the top. And this is the section view labeling done. Now we'll have to move on to dimensioning. So in my layers list, I'll make my dimension layer active. And also I want to go to my dim style and quickly change my parameters. So in the symbols and arrows, arrow needs to be 3. In the text size needs to be 3.5, text height. Then here it needs to be above the dimension line. This offset needs to be 0.5. I have to check the aligned option, then move on to fit, both text and arrows. Check both of these options, then to primary units and select this. Quickly check the preview, it looks fine. Okay, and close. And now all I have to do is dimension. So DIMLIN. So from here to here, and another one. So tap enter again to repeat from here to here. This is 15. Okay. And then DIA for diameter. So I have one here. See if I can place it inside. looks kind of crowded, so I'll place it outside. Repeat the command. And the last one right there. I have my part dimensioned as well. Now we can move on. Let's add some tolerance to this part. So we give the tolerance command. And from here we can select the symbol. This is the symbol for flatness. Then we have to type in the value 0.25 and click on OK. After that, place it somewhere. For example, here. And I need to point to the surface. So I'll use the leader command and click on the surface here. NEA enter to click here. Then create a surface, a leader line like this. And click once more and tap enter. Now look down here at the bottom. Have to tap enter twice and then select none as the text. And now we have to select this flatness symbol and move it to the end of the line here. And we have added flatness to our drawing. Now let's add a reference datum to this inside cylinder. So first we need to go here and delete this dimension and place it here, and you'll see why in a minute. So DIMLIN, place it here and double click it and write in %% to get the symbol required. And now we want to create our datum, and our reference datum is nothing more than a leader styled differently. So we type in our leader style command here and we create a new one, a new leader. We can say that is for our tolerancing needs. Continue. And in this box here, we need to make sure we have the frame text around our leader and click OK. Make sure this is set. So MLEADER and snap to the arrow here. MLEADER. Up to the arrowhead here. And the A value. Our arrow here is very small, so we have to enlarge that. We'll go to our leader style that we just created and we'll modify the arrow size. To be 3. OK and close. And this updated for us. And now we have to place the data that references this datum. So first Let's clean up our dimensioning here. DIMLIN and place it here. And the other one here, because I want to add in this dimension here. So DIMLIN, enter. From here to here, I can either place it inside or outside. So let me place it here. Double click and write in there %% to change it to a diameter. And now we'll have to create our tolerance here. So we want to add a tolerance, so TOL, enter. And this should be concentricity for a diameter, and the value is 0.1. Okay, and I'll place it here. Now I'll use my leader command to draw a leader from here, like that. Tap enter and select none from the list. And now move this here. And now we have our concentricity placed as well as our flatness. So our flatness is a single feature and our concentricity is a related feature, which relates to the datum, the reference datum A here. I mentioned in the beginning about parametric design. It's a separated tab here in the AutoCAD, and we can use this to have different dimensions depend on one another. So let's first go into our layers and disable some of these. I'll go to layer 0 here and I'll disable the axis, also the dimensions and the hatch pattern, and that's it. Close that. So now we have this geometry to work with, and I can go here and select a dimension for this, so a linear dimension. I can say that horizontal dimensions from here. So from here, snap to the intersection there. From here to here. Let's see. So once again, go here to the linear dimension and snap to this intersection here. And here. And it asks me how much I want this to be. And it says that if you don't do anything, then this dimension will be known as D1 and it will be equal to 20 units. If I click outside, that is the dimension. Okay. And let's see what happens if I do this again. And only this time, I'll dimension the outer part here. And it says 40 already, but if I click, it waits for something. And I can tell it this dimension should be 2 times D1. Okay, and click outside. And it remained unchanged, but the dimension remained unchanged, but here we have a function and it says this dimension depends on D1. And if D1 is 20, then D2 will be 2 times D1. So if I change this to a different value, let's say 25, then this also updates as well. Well, let's Control Z, because this happened because I have no geometric constraints. So this tab is full of geometric constraints and this tab is full of dimension constraints. So I only applied the dimension constraint and said this, let's Control Z. So this diameter was 20 and this diameter was 2 times that. So if I change this to 25, this also changed to 50 instead of 40. And I can continue on with this. So a linear dimension on the bottom here. And this should be equal to 3 times D1. Click outside. So it remains unchanged. And what about the height here? Well, I can, so this is not dimensioning in the proper way as we know it. It's constraining the geometry from here to here. It's 15. So we can say this is equal to 3/4 of D1. Okay. And the other dimension from here to here. So this is D1, so it's 2 times D1. So D1, so this is 5 halves times D1. Okay. And I can also give some restraints, some constraints here to the circular geometry. So the diameter here, largest one, should also be 3 times D1. And the next one is 2 times D1. And the last one is actually D1. So this is the dimensional constraint of the part. So we constrained all of the dimensions, but we haven't yet constrained the geometry. So if I change the value of D1 from 20 to another value, all of these dimensions will change with respect to D1, but the geometry will not actually keep its relationship as you see it from one line to the other. For example, let's give this a value of 25. As you can see, this changed all of the dimensions, but the relationship between the geometry edges didn't change because we didn't apply any geometric constraints. Let's Control Z. Now I can go here and in my dimensions tab here, the dimensional constraints, I can go here and either show or hide all so that they don't appear to be like in front of our drawing here, and we can concentrate on working with the geometric constraints here. Well, I can go here and start adding in the constraints here, as I did for my geometrical, for my dimensional constraints. So these here, or I can use this auto constraint feature. So I can do either this or that. First, I want to give another dimension from here to here. And this dimension should be exactly an equation d2 minus d1 divided by 2. So we'll hide this for now. We'll select the geometry and we'll go here and say auto constraint. And it did add a lot of constraints to my drawing here. If I show the geometric constraints, the dimensional constraints, we can see all of them at once, and we can change the diameter d to be 35, and we can see how much of that dimension and how much of the proportions that kept, and we can try to repair some of that. For example, here we can see this is off center a bit, so we can go to the dimension, linear dimension again, and say that I want a dimension from here to here of exactly d3 minus d2 over 2. And that kind of aligned. And also we can change it back. Let's see, where is that d1 here? Let's set that to 25 so we can see it better. This kind of moves along like so. So you can try to hide all of these to see it better, or try to struggle with it. Try to move that a bit. F3 turned off. There you go. This should have been here. So let's place an equal constraint for this and this. And we can build our geometry so that we have a fully parametric design that helps us to draw at any size the part that we have designed ourselves. And also we have a parametric table here in which we can see all of our variables that we have created, and also we can change them to match our specific requirements. Also, I reverted this to the initial phase, and to make it steady and not move all over the place, I can go here and choose this lock symbol to fix some of the points. So this point here, center of the circle, and this point here, so that when I change the value of D from 20 to 30, see, this doesn't move around as much. It just resizes and helps me build a proper drawing. And I want to go here to parametric and change this to something like in the beginning it was like 20, so I want to make it like say 15. Okay, and make it smaller. And now I'd like to turn some of the layers back on again. So let's turn on the axis layer, the dimensions layer, the hatch layer, and close this to see the result. So most of the geometry remained as expected. Also the dimensions changed, they got updated based on my my dimension that I gave, the D. And I can clean this up since some of these are not really at the proper position. But it's a lot less work than actually redrawing the whole projection, the whole part. Yes, and that is how you use parametric drawing to improve your drawing skills. Let me hide all of these. And it doesn't even look like we have some parametric things around. But if we go to the parametric tab and go to the parametric table here, we can see that we have them.